Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my brilliant co-host, Victor. Before we dive in, I want to remind our amazing listeners that if you're enjoying our show, please rate us on your favorite podcast platform. It really helps us reach more people passionate about decentralized tech.
Absolutely, Sheila. Your support means the world to us. Now let's jump into today's topic. We're continuing our journey through Chapter 2, Fundamentals of P2P Networks, and we'll be exploring the exciting world of real-world applications of P2P networks.
That's right, Victor. And to kick things off, I have a tricky quiz question for our listeners. Here it is. What was the first widely adopted peer-to-peer application that brought P2P technology into the mainstream and caused a major disruption in the music industry?
Ooh, that's a great question, Sheila. It really takes us back to the early days of P2P networks. I think our listeners might need to dig deep into their tech history knowledge for this one. It's fascinating how a single application can have such a profound impact on an entire industry, isn't it?
Absolutely. Now, before we dive deeper, let's quickly recap some key terms for our listeners. Victor, could you remind us what exactly a P2P network is?
Of course. A peer-to-peer P2P network is a distributed network architecture where participants, called peers, share resources directly with each other without the need for a central server. Each peer can act as both a client and a server, making the network highly resilient and scalable.
Thanks, Victor. Now, let's start exploring some real-world applications of P2P networks. I've heard a lot about BitTorrent, but I'm not entirely sure how it works. Could you explain it to me?
Certainly. BitTorrent is one of the most well-known P2P file-sharing protocols. Imagine a potluck dinner where everyone brings a dish to share. In BitTorrent, instead of food, people share pieces of files. When you want to download a file, you connect to multiple peers who have the file, downloading different pieces from different peers simultaneously. This makes downloads faster and more resilient.
That's a great analogy. So, if BitTorrent is like a potluck dinner, how does it compare to a traditional client-server model?
In the client-server model, it would be like one person, the server, cooking all the food and serving it to everyone else, the clients. This can create bottlenecks if too many people want food at once. P2P systems like BitTorrent distribute the load, making it more efficient and robust.
I see. Now, I've also heard about cryptocurrencies using P2P networks. How does that work?
Great question. Cryptocurrencies like Bitcoin and Ethereum use P2P networks in a fascinating way. Each participant in the network, often called a node, which is essentially a computer connected to the network, maintains a copy of the entire transaction ledger. When a new transaction occurs, it's broadcast to the entire network. Nodes then work together to validate and add these transactions to the ledger, creating a decentralized consensus.
That sounds complex. Are there any challenges or potential issues with this approach?
Absolutely. One major challenge is scalability. As the network grows, it becomes harder to maintain consensus quickly. There's also the issue of the 51% attack, where if a single entity controls more than half of the network's computing power, they could potentially manipulate the ledger.
Interesting. It seems like P2P networks are used in communication as well. Wasn't Skype originally based on P2P technology?
You're right. Skype's original architecture was indeed P2P based. It used a distributed network of user devices to route calls and messages, which made it very resilient and allowed it to scale rapidly. However, it's worth noting that Skype later moved away from this pure P2P model to a more centralized architecture after being acquired by Microsoft.
That's fascinating. It makes me wonder about the future of P2P applications. Are there any emerging trends or exciting new applications we should keep an eye on?
Absolutely. One area to watch is content delivery networks, CDNs, based on P2P technology. For instance, the Interplanetary File System, IPFS, is a P2P protocol for storing and sharing data in a distributed system. It has the potential to create a more resilient and censorship-resistant web. Another exciting area is distributed computing projects like BOINC, Berkeley Open Infrastructure for Network Computing. These projects use the idle processing power of millions of computers to tackle complex scientific problems, from searching for extraterrestrial intelligence to folding proteins for medical research.
Wow, that's incredible. It really shows the power of collaboration on a massive scale. Now, I'm curious about a potential pitfall. How do P2P networks handle security and privacy concerns?
That's a critical question, Sheila. Security and privacy are indeed significant challenges in P2P networks. Because data is distributed across many nodes, it can be more challenging to control access and ensure data integrity. However, many P2P systems use advanced cryptography to secure communications and verify data. For example, in blockchain networks, cryptographic hashing and digital signatures are used to ensure the integrity and authenticity of transactions. In file-sharing networks, encryption can be used to protect the content of files being shared. That said, users should always be cautious about what they share on P2P networks and be aware of the potential risks.
Thank you for that explanation, Victor. It's clear that while P2P networks offer many advantages, they also come with their own set of challenges that users and developers need to be aware of. Now, I think it's time to reveal the answer to our quiz question. The first widely adopted P2P application that brought this technology into the mainstream and disrupted the music industry was Napster. Launched in 1999, Napster allowed users to share MP3 files directly with each other, bypassing traditional distribution channels. While it was eventually shut down due to copyright issues, it paved the way for future P2P applications and forever changed how we think about content distribution.
Absolutely right, Sheila. Napster's rise and fall is a fascinating chapter in the history of P2P technology. It really highlighted both the immense potential of P2P networks and the legal and ethical challenges they can present.
Indeed, Victor. Now that we've covered this bit of P2P history, let's wrap up by summarizing the key points we've discussed today.
Great idea, Sheila. Here's a quick summary. Point 1. P2P networks have a wide range of real-world applications, from file sharing to cryptocurrencies and distributed computing. Point 2. BitTorrent revolutionized file sharing by allowing users to download pieces of files from multiple peers simultaneously. 3. Cryptocurrencies like Bitcoin use P2P networks to maintain a decentralized ledger of transactions. 4. P2P technology has been used in communication platforms, though some, like Skype, have moved away from pure P2P models. Point 5. Emerging applications like IPFS and distributed computing projects show the continuing evolution and potential of P2P technology. 6. While P2P networks offer many advantages, they also present challenges in terms of scalability, security, and privacy that need to be carefully considered.
Excellent summary, Victor. I hope our listeners have gained a deeper appreciation for the diverse applications of P2P networks and their potential to reshape various industries.
Absolutely, Sheila. And to our wonderful listeners, we'd love to hear from you. Visit crashcasts.com to join our Discord community and share your thoughts on today's episode. If you're enjoying the show, please consider supporting us on Patreon. Your support helps us continue bringing you in-depth content on decentralized technologies.
Until next time, keep exploring the fascinating world of P2P networks.